And welcome back, friends. This is St. Raz, and we are here at Cajun Coding, or continuing on our Java journey, and we're starting on the String3 series of exercises there. If some of the buttons or text looks a little bigger here, that's because I've zoomed in a little bit. I looked at some of the playbacks, and it was a little hard to read, I think, sometimes. So hopefully this is going to make it a little easier on your eyes. I use quite a large screen when I'm making these, so I didn't notice that there might be any problems there. But hopefully this will make it a little bit easier for you. We're exploring some more advanced concepts in manipulation of strings. In this particular exercise, we're going to start out with count YZ. Given a string, count the number of words ending in Y or Z, so the Y in heavy and the Z in fez count, but not the Y in yellow. And we'll say that a Y or Z is at the end of the word if there's not an alphabetic letter immediately following it. Note, character is letter, car, tests if a character is an alphabetic letter. We're also not going to be case sensitive with this exercise, so let's go ahead and get started here. Let me see. And we've got a count, which we'll initialize to 0, of course. And we're going to be returning the count at the end. And here's our logic in the middle here. Now, we're not going to be case sensitive. And I don't think we're going to be case sensitive with the input or the output. So what we can do is we can just replace our string with string. And we'll call the method to lowercase. Let me see. And we'll put a for loop in here. Oops. There we go. String. Alright, so if, let me see, string character at I equals, let me see, Y or equals Z. Okay, and we're going to do either one of those. We're going to enclose that in parentheses. And I'm not sure if I noted this before. When you click on a line here where you've got a brace or enclosure, any kind of bracket or brace or anything, it'll highlight the one that it's closing. And if you conversely, it'll highlight the one that it's that closes it if it's opening. I should say the one that it's, the one that it is closing. That's the opener right there. If you're on the same line and your cursor is right to the right of something, it'll show that as well. So here, see, it lights up there. Here, it shows that it's opening and it's closing there. So I did not notice that earlier. That's going to help out a lot. So anyway, so we're going to check if the character at current index I is a Y or a Z, and the character right after is not a letter. We're closing the character at, closing the is letter, and closing the if. And then we put our code block there. Now, it's not character is letter, it's if it's not. So we put the bang there. And then we're going to increment count. Okay. So if it's the case that we have a Y or a Z, and it's the case that the character right after is not a letter, okay, Now we do have, let me see, we're going to have an edge case because this is going to run over the end of it because we're checking the character right after if we don't have a character right afterwards. So we're going to have to handle that. So if, let me see, if I is equal to, if it's the very last character, string length minus 1, that's the very last index. Okay. And we're going to check to see if we have one of those. Is equal to y, or is equal to z. Then we're going to increment count. And then we're going to continue, which means that we won't hit this if. We'll go back to the top of the loop. Is that going to be it? Yeah, it looks like that's it. Now just a moment here, and we're going to be running these more. We've got character is letter. What do we have before? We had another, oh, we've been using the math class. Remember the math class where you use math, max, and then we have the letters, the parameters that we put in there. It returns the biggest one. We also have minimum, math min. Okay, but math right here, that is an object. Okay, Java is an object-oriented language. It's an example of object-oriented programming. Almost everything in Java is an object, where you're storing characteristics. An object is an instance of a class. A class is just a definition of something that's held in memory that an object of that class type conforms to. We could go really into depth with it, but there's lots of custom classes that are available that you can create a class of whatever you need. Basically, say you're doing a database, you might have a class called client or customer or something like that. It would have attributes like a name or an account number or an amount that's owed or something like that, you know. But along with those custom classes, which we're not going to get into right now, there are also included classes with the Java language. There's a lot of things you don't want to reinvent the wheel with every program that you write. There's logic, there's characteristics that you're going to need, and that the designers of the language knew that people were going to need, so they included that as part of the language. An example of that is the math object. The math object is part of its character, as part of its the possibilities that it has. There are methods that can be used that we can call on the math class, and minimum, min, max, abs for absolute value. Those are some of those methods that we can call on the math object, and then we have input that we put in. For example, we need the largest of two values, or the smallest, or the absolute value of an expression that we place in there. Those are things we can do with the math object, and this is not part of our program. Let me get rid of that. Another object we have is the character object, and if we need to check to see if something is a letter, we load the character object. We call the isLetter method using the dot operator there on the character object, and then as part of that call we pass in a character value, and the result will be that character, the result would be the isLetter method called on the character object, passing in the value of a character. This is the parameter. This is the value we're passing in. This is the character object, and that would return a value. It's a Boolean, true or false. It either is a character or is not a character. Excuse me. It is or is not a letter. This is an alphabetic character. So if it's not part of the Latin alphabet, it would return false. If it is a character, A through Z, then it would return true. If it is a letter, rather, A through Z. So, and we're going to see more of those. I noticed we had very few objects and we weren't doing a lot of those earlier in the exercises, but it looks like we're getting into that now. So you want to get used to that. It's a very important part of the Java language. And going on to the next exercise, without string, given two strings base and remove, return a version of the base string where all instances of the remove string have been removed. And this is not case sensitive. You may assume that the remove string is length 1 or more. Remove only non-overlapping instances, so with XXX, removing XX leaves X. Okay. Alright, let's see what we've got here. Alright, so we're going to be returning a string, so let's go ahead and set that up. We're going to do a string answer, initialize it to empty. Notice this is not case sensitive, so we can do string base equals base to lowercase, and we can do string remove, and we're going to do, oh wait, I'm doing that wrong. You know what, we already have a string called base, and we already have one called remove. We're just reassigning values. Here we go. Remove to lowercase. I was putting string, the keyword string here, declaring the data type of the variable base, but I don't need to do that. We already have the variables already been declared and initialized. All I'm doing here is reassigning to the base variable everything that's already in base, but calling the to lowercase method. So it's going to make everything lowercase. That way we don't have to worry about case sensitivity. Let me see. And we're going to, let me see, actually we might, let's do, oops, let me see. And we're going to use this to make things a little easier to read and a little shorter, a little less typing. So we're going to do length B, length of base, so base length, and we can do len R for remove length. Okay, and we're going to return at the end of our function here, we're going to return answer. And let's get into the middle of it here. So a for loop. Okay, I is len B. Okay, and within this, let me see, if base substring I, and it's going to be the size of the remove, and if it equals remove, then if it equals, we're not going to add it in there. So we're just going to skip over it. So we're going to increment I by the length of the remove chunk there. We're going to do it minus 1 though, because as we return to the top of the for loop, it's going to increment by 1 automatically. So we're going to jump forward by 1 less than that. Let me see. And let me see. Actually, there's only one other possibility it doesn't match. So I'm not going to use a continue. You could use a continue right there, and it's going to send you back to the for loop. But there's only one other possibility, so we'll put it in an else, which means that it doesn't match. So what we're going to do is answer is going to be added. We're going to append to answer base. I'm going to just use character at like that. Now there is one edge case that we need to check. If, let me see, if I plus length of remove is greater than len b base, that's going to, in our check, we're going to overrun the end of the string, and we don't want to do that. So if it looks like that would happen, then we are going to, obviously it can't match because we're running over the end of it. So we're going to add all of that to the end of answer. And we're also going to break out of the for loop because we won't need to iterate through it anymore. I think that should be it. Let's see how many parentheses or semicolons I missed. Okay. Our very first test here. What happened? This looks right. He there. Look at that. Looks like it's sort of case sensitive. Okay. So when we're taking stuff out, it looks like it's not case sensitive when we look, but we don't want to change the case that's already there in the original text. So what do? And these are the problems right here when we make everything lowercase. It doesn't want us to do that. So let's go ahead and remove that. But we still need it to not be case sensitive. So what we're going to do is right here where we check to see if it's equal, what we're going to do is take base substring. Okay, we're going to make this lowercase dot to lowercase empty parentheses. I'm going to see if it equals remove dot to lowercase. So now they're all going to be lowercase in this check, but even if they're all lowercase when we run this check, it's not going to change the text in the string itself. And if we end up writing to answer like so, it's going to write just what's in base. It's not going to change it unless we also called to lowercase in this instance where we're appending or where we're writing. But just because it's to lowercase in this string, in this check here, doesn't mean that it has to be here. It can be if we specify, but in this case we're not. So that should do it. Oh, what did I do? Cannot find to lowercase. What did I do? Let me see. Base string to lowercase equals remove to lowercase. Oh, you know what? Right here, I don't have the empty parentheses. I wonder if that's all that is. There we go. And that works. That's my coding, warts and all. Okay, next one, equal is not. Given a string, return true if the number of appearances of is. And remember the Clinton error, depends on how you define is. Okay, return true if the number of appearances of is anywhere in the string is equal to the number of appearances of not anywhere in the string. Now this one is case sensitive. Good old case sensitivity. Okay, so we're counting and we're comparing. So let's do an int is count, and we're going to start that at 0 before we start counting, and int not count. Likewise, and we're going to return. This is return true, so this is Boolean. So we're going to return is count equals to not count. And of course in the middle here is where the fun happens. Okay, let me see. So who knew we were going to do a for loop? String length. Oops, there we go. Okay, so if let's do this first. We're going to increment is count. And if it's equal to not, then we'll increment not count. Okay, now there are a couple possibilities here. What if we overrun the end of the string there? We don't want that. So if I plus, now we know we're checking for is, so I plus 2 is greater than string length, and okay, and we know we're checking for not, which is 3 characters. So if I plus 3 is greater than string length, and now we might run into some edge cases where we have like super short strings, but let's see what we've got here. Of course, I'm missing a parentheses. Okay, right here we've got if. The conditional is always inside parentheses. So if you look at the very end of the if, and you've got a parameter that you're passing in, and you only see one closing parentheses, then obviously that's wrong. It might not be all that's wrong, but it's definitely wrong. Notice that we've got a cursor to the right of the parentheses here. Now this one's highlighted, which means that as far as our numbers of parentheses are concerned in that conditional block, then that's correct. And right below it, check it out, another single parentheses. So, all right, let's see what we got. And thanks to my zooming in, it looks like we ran over. Why did we run over the end of it here? This is not. Okay, so if, is it greater than or equal to? That doesn't seem right. No, that's not. Okay, so if so let's say I is, where's the short one? Oh gosh, they're all so long. Really? The one that's empty is complete. The one that's completely empty is true. Okay. Okay, so I'm overrunning the end of it. So what's going on here? Let me see. If I plus 2 is greater than string length is plus 1. That doesn't seem right. It's not. Oh, you know what? That's wrong. That's silly. Those are the edge cases. I want to make sure that was not the case. I've got this backwards. If it's less than, we'll be okay if it's less than. If it's greater than, we need to skip over that though. See? There we go. See, so that took care of that problem. We seem to have some logic problems here. What's going on there? But we don't have our out of bounds exception. So we fixed that immediate problem. What's going on here? This is false. Why is it saying false when it should be true? Is not. Count, not count. And there it is. It was equal to or. It was equal to or. However, I had I had it greater than, not less than, so that works. There we go. With just a less than, we weren't reading the very last chunk there, but there we go. Let me see on the next one. gHappy. gHappy. So we'll say that a lowercase g, any string is happy if there's another g immediately to its left or right. Return true if all the g's in the given string are happy. And let's see, we got two g's right next to each other. True, they're happy. One g by itself, no other g's, that's false. And this one's false. We've got happy g's here, but we've got one that's by itself. Return happy if, return true if all the g's are happy. So if there's one exception, so what's that mean? So logically, that means that we can return true by default. And what we're going to do is look for the exception. As soon as we find one exception that's not all true, then we can immediately return false. And that's what we're going to do. So let's go ahead and set up a for loop. Let's do our length. Now, we want to look before and after the G when we find it. And in doing so, what we're going to do is we're going to run those edge cases where we look at the first character and the last character. We're obviously not going to look at before and after it. So if I equals 0, it's going to be one edge case. If I equals length minus 1, that's the very last index. That's going to be another edge case, and then neither edge case would be anywhere in the middle there. So if I equals 0, now we want to check to see if it's a G. If str character at I is equal to G, and character at I plus 1 is not equal to G, return false. Okay. Now for the very last character, we're going to check if string character at I is equal to G and character at I minus 1 is not equal to G. Then we're going to return false. And just to be a little consistent here, let's go ahead and fix that. There we go. Alright, and anywhere in the middle, if character at I is equal to G and character at I minus 1 is not equal to G, and character at I plus 1 is not equal to G. And we're going to need some extra parentheses here. Because this is only going to come out as, let me see, false. So we're checking the character has to be G, and neither of these can be G, front or back. So not G here and not G here. And if that is the case, then we're going to return false. Otherwise, we return true. Let's see how that works. Well, where is that? Missing or the legal start of expression. It does not tell me where that is. Let's see. This closes that. This closes that. This closes that. This closes the. Well, wait a minute. Why this is not closing our for loop? Let me see. Oh, this closes this if. This if is nested in this if. Where's that? So this is actually here. And we should have another closing brace here. Closes here. This closes that one. This closes our for loop. This closes our function. Okay, looks like we've got some good results here. What do we have here? Oh, we're out of bounds here. And then we have the 1G. Now this one is empty, it's true. Now if we have just one character, then we can't, if it's a G, it can't possibly have a neighbor. So it has to be alone. So if string length equals 1 and return false. Now I has to be less than string length. Okay, so if it's a G, we return false. If it's only one character and it goes to the for loop, it basically is not going to execute it, so it'll be fine. See? Okay, now what about this one? Why are we out of bounds here? So, let me see, if it's equal to 0, so we check if return false. Now when we go to the second one, it's 1, so I equals 1. Well, that would be the last one. Oh, then it goes on to this one. Oh, wait a minute. I'm not sure about that one. Why is it doing this? So, string line 12. So it's here. Why is it hitting this? Oh, you know what? Because if we go down to here, it'll run this. So it ran the last character, but we found a G, so it did not return false. And because it didn't return false, it goes down to this statement. When it checks this one, it checks the character in front and in back. Well, there is no character in the back. So what we should do here, return false. And I think we should put a continue here. Why did that not work? If it's the last character, no, we should put a break. Because it's the last character. That didn't work either. What's going on here? Okay. I might be overlooking something obvious here. Okay, so when we run this, what happens? Line 12 out of bounds. Okay. So it's this line. What do we have here? When we have the first G goes through here, I equals 0. Okay, return false if it doesn't have a neighbor. It does have a neighbor, so it's fine. And then it runs this. This is not the case. It's not the last character, so it runs this. And this one, it checks, oh, you know what, that's -1. So it's checking the one before. So if it's 1, return false. How about this? Okay, return false if this is the case. But it's not the case, so we're not returning false. What if we do else, continue, and it'll go back to the for loop. There we go. Kind of had the right idea, but I wasn't running into the problem where I thought I was running into it. So it's important to read those alerts. You'll see here when we run this, it'll give us the error and string out of bounds exception. It'll tell you what line it's on, and it'll highlight that line so you can see where the problem is. That doesn't necessarily mean that's the line that needs to be changed. We didn't change that line. We had to change code above it to ensure that the situation that causes the error never reaches that line. And that's just what we did. So you'll see the line 13, it'll highlight that line. And I wasn't paying attention to this. This is -1. Okay. String index out of bounds, -1. So I think that's referring to the index. There is no -1 index because we start at index 0. But the problem with -1 is that it might be referring to a value that's not contained in the array or string because it's an invalid index. So because -1, if you recall earlier lessons, we talked about the fact that -1 is often a valid return value for value not found, index not found, object not found, things like that. So it won't necessarily cause an error. You may be listening for -1 and you may have another branch of code or logic that is intended to handle that situation as a valid response. So, but let's go ahead and fix this. Oops, I don't have focus. Here we go. Did I go too far? Wait a minute. That's the right one. Yeah. No, that's not the right one. It was the first one, right? Yeah, there we go. I'll go ahead and fix that. It's over here. Return false, else, continue. Now it's just getting uglier and uglier. There we go. I couldn't wrap up the video without getting it back to where it ran. Okay, I think that's about 40 minutes in. So we'll go ahead and wrap this one up. But thanks again, everyone, for listening. And hope you guys have a great time coding, learn a lot. If you need anything, just if you have any requests, questions, comments, those are always welcome. And of course, like and subscribe. And I'll see you guys next time. Thanks so much. Bye-bye.